Hello students, as I had promised, I am going to have half an hour lesson. So frequently I am going to upload lessons, okay, but it will be in continuation so that you can study it one after the other. At the end of the chapter, I will compile all the sessions, okay, and put one video at the end, okay, so that you can have it together, right? So last time we have is until now we have studied directed line segment, then vector notation, how to write a vector, then addition of vectors, then zero vector, then subtraction of vectors, then scalar multiple of a vector, and magnitude of a vector in plane. One thing was remaining last time, so I will cover that today and then continue. Today I am going to teach you vector in space, okay? Yeah, so unit vector in a plane. In a plane it was remaining. What is a unit vector? So unit vector, as we have already defined, a vector whose magnitude is 1 unit is a unit vector, yeah? Right? Okay, so we have unit vectors in two-dimensional space. They are called basic unit vectors, okay? They are I and j. I is in the direction of x-axis and j is in the direction of y-axis, okay? So let me draw the coordinate axis. Okay, so let this be x-axis and origin and y-axis. Then any vector of 1 unit in the direction of x-axis will be I, and I will be the unit vector, base unit vector, and it will be given by 1 0, okay? And j will be in the direction of y-axis and it will be given by 0 1, okay? Then the question arises how to find a unit vector in different direction. So suppose if I have a vector here, right? Let me redraw. Yeah, so I have a vector here, suppose 3 2, okay, O to P, right? Then you know that when I draw a perpendicular here, this will be 3 units and this will be 2 units, okay? So let OP is a vector 2 3 2 in component form, right? Then I am drawing perpendicular, so therefore OM is equal to 2 and PM is equal to 3. Therefore magnitude of OP, if you have to find magnitude of OP, so you will write square root of 3 square. We have already learned how to find the magnitude, right? Please revise all those things what we have done. And 2 square. So 3 square 9 plus 2 square 4 will be square root of 13. Now unit vector in the direction of P or OP, okay? Therefore unit vector in the direction of OP, vector OP, is equal to vector OP divided by its own magnitude, okay? Magnitude of OP. Please remember this rule. Yeah. So it will be vector OP is 3 and 2 in component form divided by square root of 13. So in component form we can write 1 over square root of 13 into 3 and 2, which can be 3 by square root of 13 and 2 by square root of 13, right? Let me write it properly. Yeah. Or you can also write it equal to 3 by root 13 I in unit vector form 2 by square root of 13 j. Vector I and j are base unit vectors. Okay, so I hope you understood what is this unit vector. Yeah. So any vector divided by its own magnitude will be the unit vector. And usually we denote unit vectors by cap. So if A is a unit vector, then it will be represented by A cap, unit vector. Okay. So usually we are going to show it by cap. In the book also you will see many places it will be represented by A cap, B cap, C cap and so on. Okay, so let us go to vector in space, right? So in space I will draw x, y and z coordinates, axis. So suppose this is my x-axis, then this is my y-axis. Okay, and this is my z-axis. Yeah. Yes, so let me label them x-axis, y-axis and z-axis. Okay, now in space also, as we have taken base unit vectors in 2 dimension I and j, like that in space we will have in the direction of x-axis the base unit vector will be I, in the direction of y-axis the base unit vector will be j, and in the direction of z-axis the base unit vector will be k. Okay, so suppose there is a point P here in space whose coordinates are x, y, z. Okay, so join it with this. Then we want to find yeah, what is this happening? Okay, so I will move my vector here. Yeah, this is point P, and then I will have the same thing here. Yeah, let me join them. Okay, now look here, let P, X, Y, Z be a point in space. Okay, now O is the origin here, and then vector OP, okay, is equal to in component form x, y, z, and in the unit vector form xi plus yj plus zk, where vector I is the base unit vector in the direction of x-axis, is base unit vector along x-axis, then j 0 1 0 is base unit vector along y-axis, and k 0 0 1 is base unit vector along z-axis. Okay, so like that we can represent a vector in space OP. Okay, so we also know that when we draw perpendicular from P to xy plane, look here, this is the xy plane. In this plane, when we draw the perpendicular, let us call it PM. Okay, then in YZ plane, PN, and in ZX plane, look here, this is YZ plane. Now this is ZX plane, PM, PN, and PR, suppose we call it, and then perpendicular from O to when perpendicular from M to x-axis, look here, like this we are going to draw perpendicular. So this perpendicular, say it is A, then from M to y-axis, look here, like this we are going to draw the perpendicular. So this is B, and from N, okay, N is there, from P to YZ plane, and then from N to Z axis we will draw the perpendicular. So let this be C. Okay, so where OA is perpendicular, OA is OA OB, where OA is equal to A, X, okay, OB is equal to Y, and OC is equal to Z, because they are on the coordinate axis. So OA will have length X because the X coordinate of it is X only. OB, the length of OB will be Y, the length of OC will be Z only. Okay, on the coordinate axis we represent the length by the X coordinate, the Y coordinate, and the Z coordinate. Okay, then now let us find the magnitude in space. Okay, magnitude of a vector in space. Let P, A, B, C be a point, then the vector OP, okay, will be given by, okay, we have already learned how to represent OP, right? Okay, so let us write this vector. So let PABC be a point in space, then vector OP is equal to ABC, isn't it? As we have learned in the last part, or AI plus BJ plus CK, okay, in unit vector form. Okay, now what we are going to do, we want to find the magnitude of OP. Okay, so what we are going to do, draw PB perpendicular on XY plane. So like that we are going to do, draw PB perpendicular to XY plane. Look here, PB is perpendicular on the XY plane, okay, and BA perpendicular to x-axis. Okay, and like that. So in this triangle, look here, the coordinates of B, look here, this is the origin, from origin to B. What will be the coordinates of B? Because B is in the xy plane, so its z coordinate will be 0, okay? So it will have the x coordinate, it will have the y coordinate, and the z coordinate will be 0. So as you have learned in previous class, so you can write OB is equal to OB square, look here, in triangle OAB. This is right angled at A, okay? So OAB, this is the hypotenuse side. So OB square is equal to OA square plus AB square. And as you can see in the figure, OA will be A, so A square. AB will be B, which will be small b, B square, which will be the length in the direction of the y-axis, right? Now, in triangle OBP, okay? Now look at this triangle OBP. This is right angled at B, so this will be the hypotenuse side. So OP square is equal to OB square plus PB square, okay? So OP square is equal to OB square plus PB square or BP square. OB square we already found, A square plus B square. And BP square is in the direction of z-axis, which will be the z coordinate of the point P, so which is C, so therefore C square. So like this, we have found the value of OP square. So therefore, OP is equal to square root of A square plus B square plus C square. Okay. And like this, magnitude of vector OP in space will be given by A square plus B square plus C square. So how do we write the magnitude of any vector in space? Its x component is square plus its y component is square plus its z component is square in the square root form. Okay. So let us find few questions here. I have taken some questions here. So write each vector in component form and find its length. Okay. Here we have to find their length. So part A, in the component form, it will be 2, 1, 4, right? And then their length will be the magnitude of vector A, and as I told you, x component is square plus y component is square plus z component is square will be its length. So 4 plus 1 plus 16. So which will be square root of 21. We will keep the answer as it is, right? Okay. Then the next one is you can write it units. So many units it is. Then B part, vector B in component form. Look here, there is I, so minus 3. There is no J here, see? So J will be 0. And there is 4K, so 4 will be the Z component. So therefore magnitude of B. So if any component is absent, so you should write it as 0, okay? J is absent, so therefore we will write Y component 0. J is with Y, so therefore Y component will be 0. So this will be square root of minus 3 square plus of 4 square. So 9 plus 16, 25, which will be 5 units, right? So like that we get this vector, the magnitude of this vector. C, vector C in the component form. Now look here, there is J and there is K. I is absent, isn't it? There is no I. So it means the X component will be 0, Y component will be 2, and Z component will be minus 3, because Z is the coefficient of K. So therefore magnitude of vector C, which will give you the length of it, will be 2 square plus of minus 3 square. So 4 plus 9 will be square root of 13 units. Yeah. So I hope you understood it. This was not difficult, isn't it? It was very easy. Let us see few more questions here. Find k given the unit vectors. So it means these are the unit vectors and you have to find the value of k from it, right? Yeah. So let us see here. A part. A part I will write in first I will write their magnitudes. So magnitude of A first part minus of k 1 by 4. The magnitude of this is equal to 1. So this will imply square root of minus half square plus k square plus 1 by 4 square is equal to 1. So I will square inside and I will square both the sides. So therefore 1 by 4 plus k square plus 1 by 16 is equal to 1. Okay. So I will take the other two on the right hand side. So therefore k square is equal to 1 minus 1 by 4 plus 1 by 16. So 16 can be the LCM for all of them. So the first term 1 will be multiplied by 16 minus second term will be multiplied by 4 and third term no need to multiply, but because we are opening it with minus signs I will write minus with them. So 16 minus 4 12, 12 minus 1 11 by 16. So 11 by 16 k square, therefore k is equal to plus minus square root of 11 by 4. Why I am writing plus minus? Because k is the y component, isn't it? So it can be positive, it can be negative. In both the cases it is going to give you the unit vector, right? Now second part I will copy there on the next page. Why it is not giving me? Yeah. Okay. So here magnitude of this vector, as I did in the earlier case, is equal to square root of k square plus 2 by 3 square plus of minus 1 by 3 square, and this is equal to 1 because it is already given that they are unit vectors. So I will square both sides. So therefore k square, the square root will go 4 by 9 plus 1 by 9 is equal to 1. 4 and 1 5 by 9. So I'll take it to the other side, 1 minus 5 by 9. 9 minus 5 4 by 9. Okay. So therefore k is equal to, as I told you earlier, plus minus 2 by 3. This is the value of k. Okay. So I hope you understood how I found that. Okay. Now the remaining two questions I am leaving it for you, right? So this is homework for you. This is homework for you. Please try them yourself like this only. Now this I am going to solve here. Find the possible values of m when it has a length of 14 units, square root of 14. So what I will do, magnitude of minus 2 m1 is equal to square root of 14. Therefore square root of minus 2 square plus m square plus 1 square is 1 is equal to square root of 14. So therefore I will square both the sides. So 4 plus m square plus 1 is equal to 14. 4 and 1 5 will go there. So 14 minus 5 will be 9. Therefore m will be plus minus 3, isn't it? Like last question. So I hope you understood this part also. Second part, should I do it? Okay, let me do it here and then I will stop. So magnitude of 4 minus 3 and m, this vector is equal to 6 units. Okay. So therefore square root of 4 square plus of minus 3 square plus m square is 6 on squaring both sides. So 16 plus 9 plus m square is 6 square 36. 6 and 9 25, 16 and 9. So it will go there. So 36 minus 25. So m square will be 11, right? So m will be plus minus square root of 11. So this is the answer for m again, another from the other vector. Okay then, so I'll stop here. Okay, so I hope you enjoyed this lesson. I will continue next time, right? I wanted to do more questions. Let me check here what else is remaining. Yeah, here you had to find 2a plus c. So let me do one more question and then I will stop. So a part, 2a minus c. Okay, so 2 times a minus c will be given by 2 times the component of vector a minus the vector c in component form. This will be 2 times minus 1 minus 2 and minus minus plus 2. Then 2 times 1 is 2 and minus 2. And 2 times 3 is 6 and minus 4. So this will be 2 minus 2 0, 2 minus 2 0, 6 minus 4 2. So this is the answer of this vector. Okay. Let me do b also. So 3b plus half c. Okay. So 3 times b means 1 minus 3 2 plus half times c means minus 2 2 and 4. So it will be 3 times 1 3 plus half times minus 2 is minus 1. Look here, half times minus 1 is minus 1. Then minus 3 and half times 2 is plus 1. Then 2 plus half times 4 is 2. So look here, I'll show you again. Half times 2 will be 1. Then half times 4 will be 2. Okay. So after simplification, I am going to get 3 minus 1, 2. Minus 3 plus 1, minus 2. 2 plus 2, 4. So this is the answer. I'll keep the C part for you. Okay, C and D. You can try them. Homework. Otherwise, I'll show you in the next lesson. Please like, share and subscribe my YouTube channel. If you want online lessons, please contact me on my email ID. Okay. Or contact me on my WhatsApp. Okay then, bye.